Welcome to Easy Calculus. In this video I'll be covering the substitution rule. And the substitution rule is what we're going to use in integration to do certain types of integrals. Because in integration there isn't just one straight clear-cut way to solve all these integrals. Each one you have to pick a different method. So this is the method of U substitution. That's what we're going to learn. So this is where things get a little bit difficult. So I would think it's normal if you have to watch this video 2 times or 3 times just to get the hang of it. That's perfectly fine. Just make sure you understand it, because once you get this and you practice a little bit, it becomes second nature. You'll sort of be able to do it mentally before you even write out anything. So to start, I'll give you some background about it, just so that you know where it's from. This is a little bit of theory. Okay, so the U substitution in integration comes from the chain rule. So let me ask you, what is the chain rule? Chain rule is this. If you've got a function f of g of x, composite function, and you want to take the derivative of this function, all that is saying you take the derivative of the outside, leave the inside, and then multiply that by the derivative of the outside. So it's the derivative of the outside, leave the inside, times the derivative of the inside. That's what the chain rule is. So now, if I was to integrate both sides, let's see what I get. So if I integrate this side, I'm just going to get times g prime of x. If I integrate this side, I'm just going to write the whole thing inside the integral, just so we can see it. So all I did was integrate both sides. Now let me actually do the work over here. All the integral sign does is like cancel out this derivative, because if you differentiated it, then you integrate it, you're going backwards. So now you're just left with f of g of x. I'm just going to put plus a constant, because it may or may not be a constant. Yeah, I don't have to put plus a constant. So that equals to this. Alright, and this is once again just like the chain rule. So now they make the substitution that g of x, they're just going to call that u, the inside function. So g of x equals to u. And let's see how it changes our problem. So now, and if g of x is u, then g prime of x equals to du, the derivative of u. So now let's see how that changes our problem. And it makes it a lot simpler. So now you get f of g of x is just u, so f of u equals the integral of f prime of g of x, so it's f prime of u times du. So this is much easier to do than doing something like this, where you have the x's and the composite function. So that's the point of substitution rule. After you make your substitution, something should either cancel out, or you just left with a constant you can bring in the front, and it'll be a basic function of u. And that basic function could be sine, or cosine of u, or e to the u, or u to the third power, u to some power, or 1 over u. Those are the integration formulas we know. So the point is, we're going to get some complicated integration formula depending on x. After we make a substitution, we'll be left with the u, and life is good. Alright, let's start. I am going to start you off with... I'll just start you off with an example, then I'll write down everything else I'm going to do. So the first example I'll be doing Alright, this is the first example I'm going to do. Now, in our last video, we had something similar to this, except this was a square, and then we had to square it to see what we get. And let me just change this from a 3 to a 5, just because I wanted to. It had nothing to do with the problem. So now, in the last video, we just squared it and then integrated it. So in this one, we could cube this and then integrate it, but that's going to be a lot of work, and I don't want to do that. I don't want you to do that. This is where you can use the substitution rule, because the u substitution, because we have an inside function, x plus 5, being raised to a power. So this is an example of an outside and inside function. The outside is cubed. The inside function is the x plus 5. So I'm going to say my u is going to be x plus 5. So u equals to x plus 5. Now I need to find out du. So I'm going to take the derivative. So du equals the derivative of this side implicitly. It's just dx because the constant goes away. So now I need to just plug in, rewrite my integral and plug in everything. So now this is the integral of x plus 5, but oh yeah, I made that substitution, x plus 5 is u. So it's going to be u cubed. Now dx, I don't need any x's. What was dx? Well, dx is just equal to du. Okay? So now this is my new integral. The integral of u cubed du. That's a basic integral. That's just the exponent rule that we can use. So this is going to become u to the 4th power, because 3 is the exponent, you're going to add 1 to that, and divide it by the new exponent, plus c. And now, for the final step, I need to ask myself, hey, what was u? Because they gave me x, and I'm ending up with u. What was x? What was u again? Oh yeah, it's up here. So u is x plus 5 to the 4th over 4th plus c is the answer. And then you're done. So the steps you're going to take, I'm going to write them down for you over here. First, we're going to pick our u. For 2 next, we're going to find du. For 3, solve for dx. 4, plug in and cancel. 5, integrate. 6, substitute. Okay, so it's 6 steps if you actually want them labeled out. So step 1 was, this is my integral. My u I picked was to be this inside function. Now when you pick your u, you should end up with something simpler. That's the whole point of it. You should end up with a nice function here where it's just like u to a power, or ln of 1 over u, or cosine of u. It shouldn't be worse than what you started with. That's the whole point of substitution. Okay, so I picked my u to be x plus 5. Then I found du by taking the derivative of this both sides. So implicitly I get du to dx. Next I solve for dx. I don't have to do any work because it told me that dx equals du. Now I'm going to plug in and cancel. I'm going to plug in what dx is, which is just du. Plugging x plus 5 to be u for right here. So that's the substitution I made. And then I'm going to integrate. So now it's just going to be u to the 4th over 4. Then I'm going to substitute back in when I started. Those are the basic steps to just solving substitution problems. Let's do another one. Now I have x plus 8 to the 5th power. Now you definitely don't want to multiply this out. And with the last example, if you multiply it out by cubing it and then take the derivative, multiply it out by cubing it and then integrate, you're going to get the same answer I got at the end. So now let's do this one, and you definitely do not want to multiply this because you're going to get a huge polynomial, which is too much work. So I'm going to pick my u to be the inside function, x plus 8. I got to find du. Well, the derivative of this is just dx. Woohoo, easy. Now I'm going to plug in and cancel if I can. So x plus 8, well, that's my u. That's u to the 5th. dx, what's dx? Well, dx equals du. I'm trying to get everything in terms of u. So this is just du. Now I'm going to integrate. So now I get u. When I integrate, I'm just going to say this is 5. So I raise it to 6 over 6 plus c. So my final answer is x plus 8 to the 6 over 6 plus c. So that's number 2. Pretty straightforward. Okay, let's go on. Okay, next is number 3. Okay, so for this one, you can sort of reason this out what the answer is. You know it has to be a sine, because when you take the derivative, you're going to get cosine. And this is asking, what did you differentiate to get cosine? So let's say we picked sine 3x is our answer. Well, if it was sine 3x, when we take the derivative of that, we're going to get 3 times cosine 3x by the chain rule. But then let's do the 3 in the front. There was no 3 before. That means if we put a, let's see if we put a 1/3 in the front of this, if it'll work out. So let's try it. 1/3 sine 3x. Differentiate that. The 1/3 is a constant. We don't have to worry about it. So it's 1/3 times cosine of 3x times 3, because it's derivative of the outside, leave the inside, times the derivative inside. So now the 3's cancel out, and we're left with cosine 3 of x. So the answer is 1/3 sine 3x. So we can do that without the u integration, u substitution for integration. But let's do it that way, just so we get familiar with it, because it's going to get more complicated. U is going to be equal to 3x. du is going to be equal to 3 dx. So I picked my u, 3x, inside function. I found du, which is 3x. Now I need to solve for dx. So to solve for dx, I just have to divide by 3, so I get dx by itself. So divide by 3, divide by 3. I'm left with du over 3 equal to dx. Okay, now I'm just going to plug it in and cancel. So now I have the integral of cosine of, not 3x, but u, since that's what it's equal to. Cosine of u. That's not going to be dx anymore, because I'm getting rid of all my x's and replacing them in terms of u's. It's like I'm translating from French to Latin. Okay? So in French it was x's. In Latin it's u's. Okay, so now dx is just du over 3. And the 3 over 3 is just times 1/3, so I would pull that to the front and say cosine of u du. It does not get any simpler than that. So what did I differentiate to get cosine of u? Sine of u. So the answer is 1/3 sine of u plus c. Now what was u? Oh, u is 3x. So now I can substitute. So 1/3 sine of 3x plus c is my answer. Okay, so let's go on to the next one. Okay, so now in this example, once again I have to pick my u. But before I even pick my u, when I'm finished, I should either get a constant that I can just pull to the front, or something that I can cancel out. And before I even do any work, let me just think about the derivative of which one I should pick as my u. If I pick 2x as my u, the derivative of 2x is just going to be 2. I mean, it doesn't really help me because I'm still left with the x squared plus 5 squared. I mean, it looks a little bit simpler because I have a u here, but it doesn't really help me much. But if I pick this to be my u, then the derivative of x squared is 2x. And hey, there's a 2x right here. So that's what I was talking about, where you have f of g of x and g prime of x inside the integral. This would be the f of g of x. The squared is the f part. G of x is the inside. And the derivative, 2x, is the derivative of this. That's what I was talking about when I first spoke about the theory. Alright, so our u is going to be x squared plus 5. So u equals x squared plus 5. Okay, so du is going to be equal to 2x dx. I have to put dx because I'm implicitly differentiating. Now I need to solve for dx. Well, dx times 2x equals du. I want to get rid of the 2x, so it's being multiplied. I have to do the opposite, which is division. So divide by 2x, divide by 2x. This cancels out on this side. I'm left with du over 2x equals dx. So that's what my dx is. Now I need to plug it in and cancel. So now I have the integral of x squared plus 5 does not exist anymore. It's dead to us. It's just u squared times 2x. Now what was dx again? Oh, dx is this. So it's times du over 2x. And voila, we have a nice cancellation. 2x and 2x. So now our integral just becomes integral of u squared du. Nice. And it's just so easy to work